All right, so in today's video's reference, we're going to start a new chapter in Algebra 1, and that is adding and subtracting polynomials. So this is brand new to us because in 8th, pretty much everything we've done in algebra to this point, we've had some type of reference point, and we could kind of relate it to something else we learned. Whereas polynomials and what we're about to get into, and factoring, all this other stuff is kind of brand new to most of us. So we have to work a little bit on the terminology, and then from there we'll do some examples and about how to add and subtract. Okay, so a monomial is a number, a variable, or a product of a number and one or more variables with whole number exponents. So basically each monomial has different degrees. So let's just kind of look, before we even talk about the degrees, of examples of what's a monomial and what's not a monomial. So basically it has to have an integer, a variable, and an exponent multiplied together, or just one of those things. So this is just an integer. So these are monomials. An integer times an exponent, a variable. Integer times a variable raised to an exponent. Same thing here, you can have more than one variable, and this is a rational number. That's all monomials. Things that are not monomials, so these are not monomials, are things that look like these examples here, and I'll tell you why. And so basically this is not a monomial because can't have a sum is not a monomial. Division, or you can't have a variable in the denominator. So variable cannot be in the denominator. A monomial cannot have a variable to an exponent. So this little a here wouldn't work. Variable must have a whole number exponent. So that -1 wouldn't work because we all know that really is 1 over to x, and that brings us back to that situation, which means it cannot be a monomial. So let's talk about degrees of monomials. So the degree of a monomial is the sum of the exponents of the variables of the monomial. So basically, you're literally just looking for the exponents, and that will tell you the degree. The degree of a non-zero constant term is 0. So basically, if it's just an integer or a rational number, we say that it has a degree of 0. The constant 0 does not have a degree. So we had that discussion before about like 0 raised to 0 is at 1. But as far as the number 0 and its degree, it does not have a degree. So here's some examples. So these monomials, a constant is just degree 0. This x has an assumed 1, so the degree is 1. This has the fifth, so it's to the fifth. And then this monomial, you have to add all the exponents, so 1 plus 2 is 3. And again, if you had 0, the degree there would be no degree. And there's no need to even look at these for degrees because they're not even monomials. All right, so what is a polynomial? So a polynomial is a monomial or a sum of monomials called a term polynomial. So basically, it's either one monomial or it's a bunch of them, which is polynomial. So poly is a fancy word for many. So many monomials together, basically. We'll talk about binomials. Binomials has 2 variables, and the trinomial has 3 variables. So we can talk about those, or 2. I don't even know if the words variables that should be here. Maybe terms has 2 terms, and a trinomial has 3 terms. So maybe change that word there to terms. And terms. Okay, so the degree of the polynomial is the greatest degree of its terms. So the greatest monomial is the degree. So trust me, this sounds pretty intense with all these terms, but when you actually see the examples, it's much easier. The leading coefficient when we're talking about polynomials is written so that the exponents of the variable decrease from left to right. So basically, if you like to organize things, you want to organize all your polynomials in terms of decreasing from the largest to the smallest. So that's basically the first step in adding and subtracting monomials, is making sure, or polynomials is making sure they're in order by their degree. So if you look at an example here, we have, this is a polynomial. It's 1, 2, 3 monomials. Let's go through and write the degree for each number here, or each monomial. So could someone tell me, what do you think the degree to this one is? 1. How about the degree to this one? 3. So that's a degree of 3. And then the degree of this one, if you remember, was just a degree of 0. All right, so now we got to put them in order. So putting this in order, I would write this as negative x to the third plus 15x, and then plus 3. So now that's in good order. So yeah, the degree, I would say this polynomial would be a degree of 3, because that's the highest, 3, 1, and 0. The leading coefficient is negative x to the third. And are there any constant terms? Yes, it's just, 3, like that. So again, the terminology will come as we practice these, you do them in class. So let's try one of these here. I'm going to grab a good old-fashioned pencil, and we're going to add and subtract these polynomials. So the first step, again, is a lot of organizing and putting things in order. So the first thing is, I can already tell these are not in order by their degrees. So I'm going to rewrite this polynomial as negative 7p to the fourth, then comes minus 2p to the second, and then comes a positive 3. Now over here, you could do addition like the vertical method. So what I'm going to do is I'm going to just line them up in order like underneath it. So like a big addition problem, if you will. So degree 4, I have plus 2p to the fourth. And then degree 2, I got nothing under degree 2. But I have a degree 3. I didn't make space for that, so I might just have to keep it in order. Maybe this wasn't the best way to do this method. 6p to the third, and then plus 7. So I'm just going to go with it. Sorry if this gets a little confusing. So I'm going to just add this and this, just like it's like terms. So negative 7 plus 2, negative 5. P to the fourth. P to the third, all I have, degree 3, I just have this one, so it's plus 6p to the third. Degree 2, I have this minus 2p to the second. And for constants, I can add 3 plus 7 and get 10. Sorry about that. I maybe shouldn't have chose the vertical method, but hey, it happens. All right, number 2, same thing. I'm going to put them in order. This one is subtraction. So we know it's subtraction. You get that assumed 1. So after I put them in order, I might distribute before I combined everything. That's the way I look at it. Kind of like when we were doing systems of equations. That's how we would do those. We would always, if we're subtracting the equation, we would change it to plus and negative. All right, so I'm going to put this in order here. This first one, I got 5a to the fourth plus 2a to the third. And then what's the last one? It would be plus 5a to the second. So I got degree 4, degree 3, degree 2. Minus, parentheses, we got negative 5a to the fourth. Then I got degree 3 plus 8a to the third, and then plus 8a squared. Okay, so I'm going to distribute this negative to the inside with my assumed 1. So I'm going to change this to plus, a positive, a negative, and a negative. Okay, so now I can combine my like terms, my like degrees. So 5a to the fourth, 5a to the fourth, 10a to the fourth. Degree 3, I got plus 2a to the third and a negative 5a to the third. That's actually, I'm going to change that to a minus 6a to the third. And then I got 5a to the second and negative 8a to the second. So that's going to be minus 3a to the second. I'm just going to quickly show it to you just for the heck of it, because this does actually look like it would have been better for a vertical method. So if I did this vertically, this would have been 5a4 plus 2a3 plus 5a2. And then this would have been minus negative 5a4 plus 8a3 plus 8a2. So this kind of lines up nicely. Maybe leave spaces if you're missing a degree. And then I would change this to plus a positive, a negative, and then add it up. You get 10a4, negative 6a3, and negative 3a2. Again, both the same. We'll work on different methods in the guided notes, and we'll try not to make that mistake. We should have left a space between degrees 4, and then left a space open for degree 3, so that way that could have fit nicely underneath. So there's a lot, as you can see, just looking at this, there's a lot of organizing and keeping things in the right order. So again, I hope this helps. For those of you that are curious, this is the half snow day, and I need to leave because it is actually snowing quite a bit now. And you're going to watch, if I look at the lesson here, looks like you're going to watch a couple YouTube videos, one by Math by 5, and try number 1 on page 6 with the class. And then so do it together, and then number 2 individually. So if you go to page 6, before we get to guided notes, there's a question right here, a math message. Try this one with your substitute, and then do it together as a class, and then do number 2 but on your own, see if you can get it right. So good luck with this lesson and adding and subtracting polynomials.